Hi everyone, so in this video we are going to be talking about solving exponential and logarithmic equations. So we're not going to go too far in depth for all of these, but I do want you to see a few because they are going to come up a little bit later whenever we get to finance. So you want to be able to do at least some basic ones. Alright, so let's go ahead and jump in. So first off, solving exponential equations, and specifically, these are exponential equations with an exponent on one side. If you have exponents on both sides, it can be done a little bit differently, but if it's just an exponent on one side, then here's how we are going to do it. All of these can be done using one simple word: rewrite. And by rewrite, I specifically mean rewrite as a log. Doing that makes it very easy to solve for these, right? So let's go ahead and look at number 33. First step is we are going to rewrite it as a log. So we have 2 to the x equals 30. So our base is 2. It's going to be log base 2 of, go to the other side, that's 30, so that's what's going to go inside of the log, equals x. The cool thing for this one, x is already isolated. That's actually our answer. Right? Now, for our purposes in this course, that answer doesn't really mean a lot. Right? Log base 2 of 30, I'm pretty sure most of you can't do that in your head. Right? So, what we're going to do is we're just going to plug this into our calculator and get an approximate answer. All right. So again, all calculators are a little bit different on how you can do this, but if you have a TI-84, then the easiest way to do it is if you press the math button, it's just underneath alpha, go down until you see log base. Hit that and you can put log base anything you want of anything you want. So you can put log base 2 of 30 straight into your calculator and you would get 4.91 if we round it to 2 decimal places. If you have any other calculator, then you're going to want to Google how to put a log into your calculator. If you have a very old one, you might have to use something called the change of base theorem. It's a way to put logs of any base into some older calculators that may not have the any base function. All right, that said though, let's go ahead and move on to 34. So again, we're going to start out by rewriting this. So it's log base 10 of 52 equals 2x. Right? Now remember, log base 10, we don't actually have to write the 10. So we can just write log of 52, and this one's going to be important because your calculator is probably going to have a log button that doesn't have any base with it. That's your log base 10. So that said, we are still not done solving for x because right now we still have a 2 in front of the x. Well, just like a normal equation, we're just going to divide by 2 and that would get rid of it. So x, if I just kind of flip this around, it's going to be log of 52 over 2. This one shouldn't need any fancy log base to put in your calculator. You should see a log button. Again, if you have a TI-83 or a TI-84, if you look to the left of the number 7, you should see log. That's the one that you want to press. Put in 52, make sure to close the parentheses, and then divide by 2. And we're going to get approximately 0.86. All right, let's go ahead and move on to 35. So again, start with the base. It's going to be log base 2 of 11 equals 3x plus 4. We can subtract 4 from both sides. It's going to be log base 2 of 11 minus 4 equals 3x. And then again, just divide by 3. So we're going to get x equals log base 2 of 11 minus 4 all over 3. Right? And then again, this depends on how your calculator puts it in, but when you're putting in this in your calculator, you're probably going to need to put parentheses around that numerator just so it knows to divide everything by 3. Right? And again, this one you also are going to need that log base function. So again, it's just press math, scroll down until you see log base. You can put in both the 2 and the 11. And if you put all of this in, again, making sure to put parentheses around the numerator, and then divide by 3, you should be getting approximately negative 0.18. All right, let's do one more. Start with the base. So it's going to be log base e, or ln, of 4 equals 2x minus 4. Again, it's important that you put the ln in this case because most calculators also have an ln button. Right? In the case of the TI 83 and 84, it's just underneath the log button. Right? So we're going to go ahead and finish solving this. So if we add 4 to both sides, we have ln of 4 plus 4 equals 2x. Then we can divide both sides by 2. We get x equals ln of 4 plus 4 all over 2. Again, plug this in your calculator. Any scientific calculator should be able to easily get this one plugged into it. And you should be getting x is approximately 2.69. All right, so let's go ahead and go on to some logarithmic equations. So for log equations, we're going to be looking at 2 different types. Logs on one side of the equation, and then logs on both sides of the equation. All right, we're going to start out with logs just on one side of the equation. And again, if we have logs on one side of the equation, the key word here, yet again, is rewrite. So if we rewrite this, we're going to have 3 as the base to the 4th equals x. 3 to the 4th is just something you can put in your calculator. That's 81. And then we're not quite done though, because logs do have one other little thing that we have to watch out for. We actually have to check our answers for all log equations. And by check our answer, specifically, we just want to make sure that we don't take the log of a negative number. So the number that's inside of the log can never end up being negative. Now, if we plugged it in this case, we would get log base 3 of 81. That's not a negative inside. So that's perfectly fine. We don't even have to go any further. We just need to make sure that we're not plugging a negative into a log. That's the important part. All right, that said, let's go ahead and look at example 38. So for example 38, looks like just log. So remember that's log base 10. So it's going to be 10 to the first equals x squared minus 3x. Then we're going to solve it. So to solve this one, we can subtract 10 from both sides, set it equal to 0. So we get 0 equals x squared minus 3x minus 10. Then we can factor it. If we factor this one, it would end up being x minus 5 and x plus 2, which gives us two different possible answers. X equals 5, x equals negative 2. Right? And if we plug both of those back in, five squared minus 3 times 5 be 25 minus 15, that's 10. That's positive, so we know 5 is an answer. Then negative 2 squared minus 3 times negative 2 would be 4 plus 6, which is also 10. Also positive, so in this case we have two answers. All right, let's look at 39. So for number 39, we do have logs on only one side of the equation. However, it's not just log of something equals a number. We have two different logs right now. Now to rewrite it, we can only have one log. So this is where our condensing comes in handy. To condense the log, remember the minus means divide. So we're going to put it in one log, so log base 2 of x minus 3 over x. And that's going to equal 2. All right, next up, we can rewrite it. So start with the base, so base 2 raised to the second power equals x minus 3 over x. Which if we simplify the 2 squared, that's just 4. And then we can actually start to solve this. So since there's an x on bottom, we can multiply both sides by x to get rid of it. So we're going to have 4x equals x minus 3. Next, we want x's on one side, so we can subtract x. So we have 3x equals negative 3. And lastly, divide both sides by 3. Get x equals negative 1. Now remember, we still have to check it. So when we check it, we're going to plug it back into the original equation. So it'd be log base 2 of negative 1 minus 3. And you can probably already see a problem. Negative 1 minus 3 is negative 4. We can't have a negative inside of a log. So that means this is not an answer. And since we don't have any other answers, we have no solution. All right, let's go ahead and talk about logs on both sides of the equation now. So logs on both sides is actually a little bit easier, because if you have a log on both sides of the equation, then all you need to actually do is set the insides equal to each other. Now keep in mind, this is assuming that they have the same base. So like both of these are log base 10, so we can do this. But as long as they're the same base, we're going to set the insides equal to each other. So 2x minus 3 equals x minus 1, and we get to solve that instead. So to solve it, we can subtract x. So we get x minus 3 equals negative 1. We can add 3. And get x equals 2. Now remember, we still have to check it, because it still started with a log. But in this case, we'd have 2 times 2 minus 3. 2 times 2 is 4, minus 3 is 1. That's positive, so that's good. If we check it in the other log, that'd be 2 minus 1, which is 1, that's positive, so this is good. Our answer is x equals 2. Next one, same idea. We have log equals log, they're the same base. So we're just going to put the insides equal to each other. So x squared minus 7 equals x minus 1. Now this is a quadratic, so we're going to get it to one side. That way we can set it equal to 0. So I'm going to subtract x from both sides, and I'm also going to add 1 to both sides. So we get x squared minus x minus 6 equals 0. Then we're going to go ahead and factor this. If we factor this one, we're going to end up with x minus 3 and x plus 2. Set both of those equal to 0, and we get x equals 3 and x equals negative 2 as our two possible solutions. Remember, we got to check both. So if we check x equals 3 first, log base 7 of x squared minus 7, so we can go ahead and plug in 3. That'd be 9 minus 7, which is 2. That's positive, so that's good. Let's check the other one. Log base 7 of 3 minus 1. 3 minus 1 is 2. That's positive. So 3 is an answer. We have to go ahead and check negative 2, though, as well. So we have log base 7 of negative 2 squared minus 7, which would be 4 minus 7, which is negative 3. Notice I just said negative. We can't have a negative inside, which means negative 2 is not a solution. So we only have one solution for this one, and it's x equals 3. All right, last one. Again, log on both sides, but that left side has multiple logs. So our first step is we need to go ahead and condense that. So remember, if we have a plus, that meant we're going to multiply inside of one log. So condensed, this is going to be ln of, and if we multiply x minus 6 times x, we'd get x squared minus 6x. That still equals ln of 16. Next up, set both of those equal to each other. So x squared minus 6x equals 16. And then again, we can factor this and solve it. So set it equal to 0. So x squared minus 6x minus 16 equals 0. If we factor it, we're going to end up with x minus 8 times x plus 2 equals 0, which is going to give us two possible solutions. X equals 8 and x equals negative 2. So let's go ahead and check x equals 8 first. So we're going to have to plug it into all three, but we really don't need to plug it into this last one because there's no x. Like 16 is always just going to be 16, which is positive, so that's perfect. But we are going to plug it into the other two. So ln of 8 minus 6, 8 minus 6 is 2. That one's good. Next one's just ln of x, so that's just ln of 8. That's positive, so that's good. So x equals 8 is an answer. And then we're going to check x equals negative 2. So if we plug that in, on the first one, we're already going to see a problem because negative 2 minus 6 is negative 8. That's already a problem. It's already negative, so we don't have to go any further. Negative 2 is not an answer. So x equals 8 is our one answer. All right, so hopefully that gave you a nice little overview on how to solve some basic equations for both exponential equations and logarithmic equations. And these will come back whenever we start talking about finance and we start needing to solve some of those equations there. So with that said, that is the end for this video, and thank you for watching.